Hello and welcome to the YouTube channel D Creations Resources. We are looking at different concepts from science, especially physics, maths, languages, etc. Today, let us continue our discussion about vibrational spectroscopy, specifically infrared spectroscopy. We have discussed several details in previous episodes. In the last episode, we talked about how change in dipole moment is relevant in order for the molecule to be infrared active, and how due to that homonuclear diatomic molecules become IR inactive while heteronuclear diatomic molecules are IR active. We gave an example of HCl, hydrogen chloride, a heteronuclear diatomic molecule, and we mentioned that it is infrared active. Now let us discuss some more details about this particular molecule. So if you consider this molecule, there is one hydrogen atom and one chlorine atom, right? And there's a big difference of electronegativity in between them. I hope you are able to remember that electronegativity is a property that basically describes the tendency of an atom, or if need be a functional group, to attract electrons towards itself. Now, the electronegativity of hydrogen is 2.1 and the electronegativity of chlorine is 3.0. So obviously, as expected, chlorine has more electronegativity as compared to hydrogen. So chlorine is more electronegative. That means that due to this electronegativity difference between hydrogen and chlorine, the electrons in this particular HCl bond will have higher probability of being found on the chlorine rather than on hydrogen. So, chlorine is going to have a certain partial negative charge. Usually it is denoted as delta minus, while hydrogen will have a partial positive charge, usually denoted as delta plus. That means if you consider the HCl molecule, it contains two charges which are separated by a distance. So obviously it is forming a dipole, and then there is going to be an associated dipole moment. In the last episode, we have already seen how dipole moment is a measure of charge asymmetry of a molecule, and its magnitude is going to be given as product of the charge and the distance between the two charges. And basically it's a vector quantity, so it has a direction along with magnitude. Now consider the electromagnetic radiation, here of course the infrared radiation incident on this particular molecule. So let's talk about the interaction of the electric vector coming from the radiation and this particular molecule. So when the electric vector encounters the positive end of HCl molecule, then if the electric vector polarity is positive, obviously it will repel the partial positive charge on the hydrogen atom, right? Because why? Because like charges repel. Then the hydrogen atom will move away from the electric vector and the HCl bond will shorten. Now once the polarity of the electric vector changes to being negative, it will attract the hydrogen atom because opposite charges attract. Therefore, the HCl bond is pulled and then it lengthens. The length is going to increase. Now, as the polarity of the electric vector changes over time from positive to negative to negative, the HCl bond will get shorter and longer and shorter and longer. So during this process, the molecule vibrates at the same frequency as the electric vector, and the energy of the radiation is transferred to the molecule. And at that time, what takes place is the infrared absorbance. Now, before the interaction of the radiation and this particular molecule, the molecule HCl was at rest, and the infrared photon had energy h nu. After the interaction, the photon has been absorbed and its energy has been deposited into the HCl molecule as bond stretching motion. So energy is conserved in this process since all of the photon's energy has been transferred to the molecule as vibrational energy. And in the spectroscopy, we are able to detect the absorbance of the photon by a decrease in infrared intensity at the wave number of the radiation absorbed. So it is going to give an absorption feature in the infrared spectrum of the molecule. So now in this episode, what you have learned is how do you essentially get that particular absorption peak or absorption dip, as the case may be, and what exactly is taking place due to which this particular absorbance peak is observed. So this is basically how the peak is obtained. Now we will see further detailing in later episodes. Thank you.